welcome everyone, and within this video we cover with you with most recent advances in large language models and generative AI in particular, where we're gonna take a closer look on how these advances can find its application in such a task dubbed as emotion causes analysis or emotion causes extraction, with the application of the reasoning capabilities as the one way on how we can gain the results of the in generative AI world. So without further ado, in the main outline and what you're going to be aware of by the end of this talk is threefold. So first of all, you can have an understanding on how good the actual language models for revealing the emotion states and emotion causes of the conversation participants. We also talk about and have an understanding of how to perform the alignment between the emotion state of the character and the emotion that he causes to the other participants in the conversation. And the very last one is we also cover and take a closer look on how we can experiment with the existed models and performing the related applications and adapt for your own needs. As for the resource, it was decided to go with the resource that had been composed from one of the famous TV show dubbed as Friends. In particular, there was studies that proposed as a part of the CMUAL 2024 competition. So authors of the related paper organized the dataset that's dubbed as ECF. And in particular, it represents the amount of the 1,300 conversations that were extracted from these TV shows, with in total annotated at around 13,000 utterances with 9,000 emotion cause pairs I mentioned in this annotation. And in general, what I like is the Friends TV show is actually a good example of how you can perform this task by looking at this picture, and in general, how you're watching the show, all the characters, they are good at expressing the emotion as well as showcasing on how caused emotions affects on the other characters. And in particular, authors of the related studies go with three different modalities that involves text, speech, and the video. However, and within these studies, we are focused on only a single modality, which is textual. And on the figure on the top slide, you can see that and what is the actual structure of our content and the ordinary conversations within the dataset. So we have Chandler, Phoebe, and Monica that represents a part of one conversation, where the most contribution of the authors of the related dataset represents the annotation of emotion causes that appears from one character to the other. And in particular, in speaking about the set of emotions, authors decided to go with the six different emotion states. So that might be joy, surprise, anger, sadness, disgust, and fear. In addition, we also go with the so-called neutral class, which could be emphasized the absence of the related emotions if we need. So in particular, we are starting with the analyzing of the related resource, and there are two main key findings that were taken out of it. So the first one is we take a look on how the performed alignment in between the emotion states and emotions caused on the other characters. So speaking a bit more about the actual resource, so besides the actual emotion causes, there were provided the annotation of the emotion states of the characters within the conversations. And it is worth to mention that across all of the emotions, we have exactly the same, see the correlation between the emotion state and the emotion author causes to, character causes to the other character within a conversation. So that was the first mention, and the second one is that treating the conversation as a context of the series of utterances, we decided to take a look on how far the actual motion causes can go with one utterances towards the other. And interesting finding is that the 50% of the motion causes are actually happening just within a single utterance. So that means the character may also affect on his mood itself by saying something. As well as we're going to go further with such a distance between one speaker to the other that causes the emotion, it is possible to see that we can cover all the emotion causes that were annotated in the set within the 95% if we're going to go with the history of the three utterances. So then let's take a look at the main part of our presentation, which is related to the reasoning concepts, and where we specifically take a look on what we're treating as a reasoning and how the reasoning finds its application in large language models. And finally, we also discuss on how it could find its application for the extracting motion causes. So reasoning actually represents a part of so-called common sense related tasks. So these are such problems that should be solved by people and usually force us to think in the series of the related steps. So it's better to go with a particular example as illustrated on the slide. A juggler can juggle 16 balls, half of the balls are golf balls and half of the golf balls are blue. So the question is, how many blue golf balls are there? When we're thinking about this task, we may treat it as a series of intermediate steps, where one step is like we demarcate the balls, on the second one is we demarcate it again by the colors. However, this is something that is not happening with the large language models, and for the generative AI, treating this task as it is and by straight away asking for the response may result in the incorrect answer. This is just because conceptually these models are not designed to think of the way that we tend to reason. To address this problem, so within the same studies that were proposed, such a step-by-step thinking, authors proposed the approach where instead of just direct answering the question, we can go with asking the reasoning steps. And with that, we're going to go with the question, which is called, let's think in step by step, in order to force the model separate all these responses into the individual thinking steps in order to finally extract and hopefully properly that lead to the positive outcome, the response of the given task. So within the same studies, others showcase that it is actually possible to improve the result performance. However, the question is how the same concept could find its application in emotion causes extraction, because this is more like a linguistical task when we're dealing with no structured data. And it's quite hard to implicitly extract such an information. In order to answer this question, this is what navigates me to another novel book that is represents the revised knowledge about and the universe of the Harry Potter, where the main character, which is a Harry Potter, represents a very smart guy that actually aware of the lots of disciplines and knows his application in order to optimize the world of the magic and everything that happened in the Hogwarts. Why this specifically, this book is quite interesting here, as it's not directly related to the reasoning, is just because it involves the rationality on how to break down every single problem that we have. Is the way how the main character, which is Harry Potter, acting in this book. So every single time is like he's saying, I'm gonna apply the first rule of the rationale, and here it goes to the first rule. So then it arises the question is, it's not going to be a longer spoiler, but what is this actual rule and why specifically it matters within this task. So by citing this book, it's not going to be a spoiler because it's just happening by the very beginning, and this book has many of chapters, such a fundamental aspect. But it goes as follows. So, what do you think you know, and how do you think you know it? So, this is the first rule of the rationale you have to ask in order to gain knowledge about something you don't know. You don't know in detail. So, with all of that, and we can split this utterance onto the two key components. So the first one is the factual knowledge, so which is goes what do you think you know, and the second one is an opinion towards it. So how do you think you know it? So the combination of these two aspects is actually the key way on how we can understand something that is not clear for us. So come with all of this background in this book in particular towards the sentiment analysis in particular as the one domain is just pretty much similar to the processing non-structured data. There were studies back in the 2023 proposed on an ACL conference in America where authors proposed a three-hop reasoning concept that is to a certain extent overlined with the one that we have just overview within the prior slide. And in particular, it involves the application of the three sequential stages. So given a generative AI model, we can go with asking the aspect from the context, followed by the asking an opinion towards this aspect in the information that we gained from the model and the actual generated text. And finally, we applying the reasoning on this in order to gain the sentiment level. So with all of that and dealing with non-structured data, these studies are actually proposed the way on how we can apply reasoning towards the extracting implicit information from the non-structured text. So now let's take a look on how these concepts might find a way in our methodology that's aimed at emotion extraction as well as emotion causes extraction. This is what navigates me to the main three parts that represent of our methodology that's going to be discussed further in greater detail. So these are three parts as follows. So we're going to reason at the first part on the emotion states of the one character. Then the second part, we're going to go with the emotion causes that this character causes to the other speaker within the conversation. And the last part is an additional where we attempt to revise the reasoning aspects in the part two in order to combine all these knowledges together. Okay, so with all that, let's now move on to the part number one, where we applying all the steps that we overviewed so far for the extraction of emotion states. So in the input, we have a context that represents a textual part of our conversation that ends to the particular target or utterance of the speaker for which we have to extract the emotion state. So we're going to go with the three different steps, and for that we're providing the following textual questions. So in the step number one, we're going to go with the question that sounds as follows. Which text bonds are possibly cause the emotions on the target? Once we retrieve the response from the generative AI system, we follow to the step number two, which has the following question. Based on the common sense, what is the implicit opinion towards the mentioned text bonds that causes emotions on the target and why? So asking this question, we obtain the knowledge about the opinion itself and gathering everything from the step number one, step number two, and the related responses. We finally move to the step number three, where we going to go with the final question. It's based on such opinion. What's the emotion state of the target speaker. And in the end, we have the certain labels that we finally use in order to perform this annotation and assess it during the upcoming training process. So without going to go with the further details, now let's switch to the part number 2, where exactly the same concepts finds its application towards the predicting the emotion causes from speaker A towards the speaker B. So within this part, the context represents pretty much the same format. Instead of that, we, in addition, going to go with the source or speaker A that goes with the first utterance. Then we have a span, or gap in between the source and the target, where target represents the final utterance of our context. So the content of the related questions for the step 1, 2, and 3 remains pretty much similar, but obviously becomes adapted to the emotion causes. The last thing is worth to note that on step number 3, we have to mention that we're referring to the last target as the last conversation utterance. This is certain specifics of their related concept is since it is designed for mention of only one object in the text, where it's now becoming source instead of the actual target. So switching towards the part number 3, where we additionally can revise our knowledge from the part number 2, involves only the application of this small box in a diagram, or that is referred to the step number 3 that represents a revised textual information, which sounds as based on such an opinion. What's the emotion state of the source character? So in other words, you can treat it as like we have a model for which we are applying the step number 2 for extracting the emotion causes, and then saying it's like, by the way, what's the emotion state of the original character that caused emotion to the character number E. So with all of that, and conceptually, that's supposed to lead to the better improvements as well as better alignment between two different knowledges. So where the first one is the knowledge of the character emotion state, and the second one is the emotion this character causes to the other. And finally, we're going to move to the model training concept. So this is where we combine all this related information within the one in the form of the pipeline. So in order, this combination represents into the following parts. It has a pipeline that is illustrated on the bottom of this diagram. In this pipeline has the input information that represents the large language models, while the output of this pipeline represents a trained version of the model. So the pipeline itself has a two-stage process. So where on the first stage, we adopt the application of we extract the motion states of the characters, while on the second stage we are going to go with extraction of emotion causes with optional application of the reasoning revision techniques. And finally, for all of these two stages, and obviously we have to have the resource that we're going to use in order to implement such a training process. And within the following slides, let's take a look on the details that we have of this resource. This is what navigates me to the experiment section. So we have pretty much, in using the collection from the Friends TV show, we have two resources that we are going to use within these studies. So the slide illustrates the statistics of the related resources that being divided on the three main parts. So the first part is related to the training data, while the rest of the two parts related to the evaluation data that represents development part and the test part. It is worth here to say that we provide the statistics for each individual class in particular, as well as for the whole information in total, and it showcases the amount of context that were used for each resource. So in particular with the to learn and train a model on predicting the emotion states, we have in total at around 12,000 input contexts, while in speaking about the emotion causes, we have in total at around 30,000 contexts for the training. It's worth to also mention is that among all the 6 classes that we have in task, as for the artificial and neutral class, becomes kind of leveraged among all the classes is just because we perform the artificial annotation of such cases where we don't have any emotions and we treat it as neutral. So with all of that and giving all of these resources, now let's take a look on how the application of these resources towards the large language models affect during the fine-tuning process. So with that, we're going to go with the FLAN T5 model that represents the publicly available model issued by Google company. So why specifically the choice falls on the FLAN T5 is that it has a various set of the available models that varies in scales. And if you wish to go with the such of those that requires your need with less amount of resources, might be your choice. That becomes the reason we're going to go with the base-sized model that is possible to adapt in a Google Colab and train it within just a single video card. Speaking about the actual stages now, so we're starting with the stage number 1 that involves the application of the first resource. And here the key notes is worth to say is that within the 4 training epochs that we applied to our model, we found that after and since the epoch number 2, there were no significant changes in models, so that the stage number 2 were counted as the terminative in terms of any further appearances and changes, and it become a source of our further experiments. That actually starting to vary with the application of different models on stage number 2. So on stage number 2, we are extracting emotion causes, and here we are actually going to go with the more approaches. So we consider the baseline approach, which is a prompt-based one, where instead of going this 3-hop reasoning concept, we go with just the single instruction by asking the question on extract emotion cause from one speaker to the other, in order to see how and what will be the difference between this baseline approach and the 3-hop proposed reasoning. As for the other attempts, for the other models, so we in addition to the baseline prompt, we go with the so-called THOR cause that involves only the application of the emotion cause extraction without reasoning revision. And in addition, the third part of our experiment set involves the model where we combine emotion causes extraction with the reasoning revision. Okay, so now let's take a look on what the actual results we got out of this application for the Friends TV show dataset and annotation of the related conversations in particular. So here it's worth to say that we have a table that illustrates the results obtained for the preliminary evaluation, which was the development set, and we have a partially available results for the official test set. In general, we have the following conclusions. So first out of them is that we showcase that the application of 3-hop approach in emotion causes slightly surpasses the results obtained by the prompt-based model. And the second key finding is that actually performing the reasoning revision is quite important, which results in additional 2.1% of performance increment comparing with the application of the concept of 3-hop reasoning without reasoning revision. And what else is finally worth to say is that in terms of the actual alignment, such a reasoning revision and the application of 3-hop is quite important because this is how we can actually reach the agreement between the emotion state of the character and the emotion this character causes to the other characters of the conversation. Here in this diagram illustrates the analyzed results that we applied towards the automatically annotated data by our trained model, and it's possible to see that we generally have the strongly correlation with the emotion states and the emotion causes. And finally, this is what navigates me to the last part of our talk when we have to discuss the demo. With all of that, let me switch to the demo section so I can proceed with the related model launching. All right, so now let's proceed with the Google Notebook, so where we take a closer look on how we can experiment with the application of the existed and saved model that in particular really represents a resource that been published on the Hugging Face platform with the related name that is highlighted and presented now, and you can see on the screen. So what's happening now, just like launching this model by passing the model parameters, we wish to perform the evaluation on the video card by using the CUDA interface. We launching the initializing the model as well as the tokenizer and adapt this to the device. So then we can be ready to use. So let me proceed with the logging information. So here is just we've seen the output of the model that been loaded with the related layers and details. Okay, so the next part is we have to initialize the code that is related to the questions that we're gonna ask our model. And in particular, we also have to have a method that implements the 3-hop approach that's been discussed within the main part of this video, where on step number 1, we asking about the aspect destruction, followed by the opinion, and finally we're reasoning about the emotion state, and provide with an additional extraction the related classification depending on the amount of classes in our task we have before mentioned in the form of the label list. It is worth here to say that we provide this example for emotion extraction chain. However, it can be easily written for emotion causes problem. And finally, in the very last cell, we can actually launch and see what would be the particular result for for the given the conversation that represents a part of two conversational turns. So we have a John who is asking like, "Oh, you made up," and the response would be like, "Yeah, I couldn't be mad at him for too long." Where when we attempt to extract the emotion related to the John, we can see that is John likely to be surprised here. While if we're asking about the emotion state of the Jack, and we can see this is going to be related to the anger. So obviously you can experiment with all this yourself, adapting for your task, but I believe this is the best way to start with this in order to tackle within this problem how you can work with the reasoning aspects and applying them for the generative AI and LLM in particular. Okay, so this is finally brings me back to the rest part of the our presentation, where I finally conclude the remaining details that were highlighted during this talk, and especially what you can take out of it by the end of this video. So first of all, and speaking about the reasoning concepts, it is worth to say that we review the 3-hop reasoning concept that you can adapt for your own needs in other task that when we are dealing with the non-structured data and wish to extract such an implicit related hidden information to authors or characters that are involved in the conversations or in the related text. Second one is we understand how to perform alignment, where in particular reasoning revision represents the main part on how you can combine emotion state of the character, as well as emotion it causes to the other characters. And we also take a look on how tackle all these models that were pre-trained on this problem and adapt them for your own needs. Obviously, there was more information to mention here, but this is the remaining part of the resources that represents all these studies. It involves the paper that was a part of the ACL 2020, 2023, and the related workshops semi-well that took place a year ago, and we published the related studies here. So this video is obviously highlights the most key concept out of the related studies. We also have the publicly available how we can proceed with this model and the related code. We've seen the trained model on the demo, but however, you can also access and take a closer look on their applications and for your manual launch and adaptation. And finally, we have shared the related competition details, so you can take a closer look on how it was organized. And with all that, and without further ado, so this is pretty much end of the video. So thank you guys for staying up to the very end with me. It was excited to share the related advances, and see you next time.